Okay, picking up exactly where we left off on the previous video. From the right, limit as x goes to 1 from the right of x over x squared minus 1. So that's going to be 1 over 1 from the right squared minus 1, which still is going to be 1 minus 0. But what I've got going on here is greater than 1 squared minus 1, which is still going to be greater than 1 minus 1, which is positive. And you don't have to write that down. That's my thought process. And again, if you can't just reason out, pick a number. 1.1 squared is 1.21. 1.21 minus 1. 1.21 minus 1 is 0.21, which is positive. And so this turns out to be positive. Again, we have a positive over a positive, so we have infinity. Then lastly, the two-sided. Limit as x goes to 1 of x over x squared minus 1 does not exist. Left did not equal right. And so there's that one. Again, what I will need to see come quiz or test time, I've got to see the non-zero over 0. If I do not see the non-zero over 0, you have not justified the use of infinity or negative infinity. So I see the non-zero over 0. I see something that indicates that you thought about whether we were close to 0 but negative or close to 0 but positive. Now you can just think all that out because this is all just thinking. So I am cool to see this, this, and this. That you kind of have the initial problem down. You do, actually this, really this line right here, that this is a complete solution. That is a complete solution. That's complete for x approaches 1 from the left. Similarly, this is complete for x approaches 1 from the right. And then when you put all of that together, this with the above, complete for two-sided. That I need to see the non-zero over 0. I need to see where you thought about how things were stacking up, positive and negative, and in the case of the two-sided, your final conclusion about the two-sided. Okay, doing this guy. Pretty much the same. Now you could do this exactly the same way, but this one we can take a little bit of a shortcut. So I'm getting negative 10 over 0. So again, we know immediately that it's infinity or negative infinity or does not exist. And yes, it's a two-sided, so maybe I should think about left and right unless there's a reason not to think about left and right. Notice right here, it is squared. Well, whenever I square something, 1 squared is 1 and negative 1 squared is 1. That when I square things, they're always positive. And so I can note on this one that because it's squared, the denominator is always positive. So, no, I don't know where the word so. And so I can just go with it. This is a negative over a positive. And so we'll get rid of an arrow and just go equals. Negative over a positive makes it negative infinity. And there's my answer. And so this one I could not do the left and right, just because I knew what the answer of that denominator was. I knew that that denominator was going to be close to 0, and because it was squared, it was going to be positive. Now, if this had been a different problem where it was cubed, well, then I'd have to break it down to left and right. So sometimes you just got to really think what's going on. And you could check that one by looking at a graph or a table as well. Okay, next one. Okay, the limit as x goes to 0 from the right of 1 over x to the 3/5 plus 7. So substituting, let's do this first, because this is legal. I'm going to do that first, split it up, because we can split up limits by addition. And I'm going to worry about the first limit in a minute. And then the next limit, that's the limit of a constant, so it's 7. So we're done with the 7 part. Now thinking about this. So the limit as x goes to 0 from the right of 1 over x to the 3/5. Okay, so that's going to be the limit as x goes to 0 from the right of 1 over, and remember that's going to be the 5th root of x cubed. And so that's going to be 1 over the 5th root of 0 cubed. Now let's go ahead and put the little plus sign in there. So I'm going to get rid of the 3 for a moment. Put the plus and cube it all. And so I've got 1 over 0. Now this is from the right. And so when I'm from the right and I cube it, and I'm 0 from the right, so it's positive, and I cube it, it's still positive. And then I take the 5th root, it's still positive. And so that's going to give me infinity. So then taking that back up here, I'm going to have infinity plus 7. So I've taken my infinity, put it back up there. Now here's the deal about infinity. Once you're at infinity, and you add a few numbers, or you add a value or subtract a value, as long as that value is a finite value. Infinity plus 7, infinity minus 7, infinity plus a billion, infinity minus 10 billion. Infinity plus or minus a constant is still infinity. Infinity plus minus a constant still goes to infinity. And same thing for negative infinity. Negative infinity plus or minus a constant goes to negative infinity. And so there's our first idea about, what's going on in infinity. That infinity plus or minus a number is infinity. Negative infinity plus or minus a number is negative infinity. Okay, next guys. So we start by substitution. And so starting by substitution, I'm going to get 6 squared minus 7 times 6 plus 6 over 6 squared minus 12 times 6 plus 36. And you can trust me, 0 over 0, which tells me nothing. Tells nothing other than to try something else. Zero over 0 as a limit's indeterminate. It tells you nothing. In this case, what we're going to do is factor. So this will be the limit as x approaches 6 from the right of x minus 6, x minus 1 over x minus 6, x minus 6, which gives me the limit as x approaches 6 from the right of x minus 1 over x minus 6. So I factor, and I got some stuff to cancel. And now let's substitute. So that's going to be 6 minus 1 over 6 from the right minus 6. That's going to be 5 over. Now reason it out. From the right. That's bigger than 6. Bigger than 6 minus 6 is really close to 0, but slightly positive. And now I have the non-zero over 0. Non-zero over 0, and then positive over positive, positive infinity. And again, you could check that by looking at a graph or a table. And let's end this video, and we'll do the next one on the next video.